Hello everyone! Today it is time to get into RStudio again for the first time in many weeks, but of course this is the most fun thing that we'll do all semester, and it's very important that we take a look at it today. So the goal today in this tutorial is to talk through descriptive statistics, a basic sort of analytical starter toolkit for understanding your data set. We already did a little bit of this a few weeks ago when we looked at the tap list data set, which is still available on Blackboard for you to look around in. What I'd like to do though is I'd like to analyze the data set that we actually just worked with just a moment ago in a previous module, which is the data set where I'm analyzing the Trump perceptions. And so if I click Import Dataset from Excel, I can browse around in my data and bring in this data set, which is in the Module 3, which is available to you on Blackboard. It's just called DAT. I strongly recommend when you're doing this that you label your data set that you end up working with dat.xslx or whatever, dat Excel file, because this is going to make it much easier to work with when you're using some of these template R files to do your analysis. I'm bringing this in. You can see that I have been able to preview the data, and it looks exactly the way that it did in the last module, where I've got Trump here, I've got the current econ, the PID, I've got birth year here, and I've got age. Birth year we won't be using actually, just because we've translated it into age already. We're going to bring this in. I'm going to say uncheck Open Data Viewer because I don't think that it's actually necessary, but we are going to make sure that first row as names is checked as we saw previously. If I click this, I import it, you'll see that in the data environment, just like we saw a few weeks ago, that DAT is the object that we've brought in, this sheet, rectangular sheet. It's got 3,165 observations, that's good. It's got 6 variables, looks good as well. If we had fewer, that would be a problem, and if we had way more variables or no variables, that would also be a big problem. So I've also taken taken a moment to upload or to open this .r file called descriptive-analysis. It's also available in that little folder for the module, and you'll see that it's got a bunch of description here in its preamble. It says this is an exploratory analysis that allows us to figure out what's in dat.xslx in the module 4 example folder. You'll see that the very first thing that we want to run is we want to make sure that our tidyverse package is installed and then it's ready to go. So what I can do is highlight this. You can press Control-Enter to run this, or most people enjoy doing this with it. Just come up here and they'll click the Run button as well. Either way, as long as this line is highlighted, you can highlight the little caption as well because there's a little hashtag in front of it to protect it from being run. You can just grab that, you can press Control-Enter, or you can press Run, and you can run that command, and you'll see that it's got all these good packages that I need. It's got the conflicts as usual, but those are actually conflicts we want because things like filter are going to be things that we want to have in here. So the first thing that I can do is I can evaluate whether or not there are any missing values in my data. And by missing, I mean, are there any blanks in the columns and rows of this data set? So if I run this, you'll be able to see this huge table that's going to give me falses sort of everywhere, right? This is not a super useful thing to look at for this particular data set because it's so large, right? But it's possible to just go ahead and reflexively do this thing right here where we say dat equals na.omit dat, which essentially says if there's any rows for which there's any of these are true, you can run this and it'll actually just eliminate that row. This is one of the first transformations that we'll be doing in the manipulation of the data set to avoid the potential for missing values. So you can run that, and you'll see that I've actually resulted in a file that still has the exact same number of observations. So it appears that there's no missingness for now in this data set. Now, one little wrinkle that I want to call to your attention here is in line 19 here. You'll see that I've used this equal sign. This is a really important R sort of feature. What I've said here is create a new object that's called dat that consists of this, na-omit dat. So as it turns out, what I've done here, cleverly in a single line, is I've actually taken this element, I've said, hey, call this element, bring it into this thing, run this operation on it, which is to say omit all of the missing values, and then take that new thing that you've created, this manipulation, and assign it the name dat. Which means what I've actually done is I've actually overwritten, I've actually replaced dat through this one line with a thing of identical name. And so this is one way that we can make changes to an existing object, is just to say, hey, this thing that has a name that we're familiar with, do something to it, and then re-establish it as the same name. And so again, this is a sort of a very low-key kind of wrinkle here that a lot of people would miss if they weren't paying close attention. But anytime we do this, where we've got dat on both sides and a sort of operation here, what it really is telling us is that we're overwriting this with a newly transformed version of the table. So the next thing we can do is we can start looking at some of these variables to determine, remember, not if there's just blanks in here, but if there's some codes that are not consistent with our code book that we had previously. So if you recall, we had dat trump here from the code book from the previous video. We saw that dat trump actually takes values, and I'll just give it a little hashtag in here so we'll be able to see. It's supposed to be going from, the range is supposed to be 0 to 100. So that means that people who said that there is 0 on this variable said that they were completely cold towards Trump, and a value of 100 said they were completely warm towards Trump. And so if we were to take this and run it, we should see a big table with 100 essentially different values and the counts of how many people out of those 3,000 said those different values. So if I do that, you can see, here we go. Yeah, I've got all kinds of different values here. The values are on top, and then the counts are on the bottom for each of these. It goes in multiple rows. So actually, if I stretch this, you'll see that it, if I stretch that and run it again, you'll see that it gets bigger. If I stretch it back, you'll see that it gets smaller. Every time it's calculating this, it's just putting the values on top and then the counts. But you'll see a couple of important problems here. The first thing is, we've got 0 through 100, that's all fine and well, but we've got two values on either side that are not values that we need. We've got -7s here, which if you go back to the questionnaire, you'll see that indicates refused. We've got 997 here, which may either be a miscode or another sort of reason why people didn't answer this question. And so we've got 19 plus 15 observations that are throwing us values that are going to end up messing up our data. So essentially what we can say, I'll put a little comment here in the dat trump here. We need to say recode -7s and 97s. These are big problems. We need to take those essentially out of the data set. So that's the first thing that we can see in this exploratory descriptive analysis. I'm going to copy this and paste it. We can look at some of the other variables in our data. So another one that we could look at, for example, would be age. That would be a good one to look at, one of our control variables. Run this. You'll see this one seems to behave more nicely. We've got people who range from 18 to age 92. We've got somebody who's 92-year-old in this data set. That one looks to be just fine. My econ variable, my independent variable, is one that I probably want to take a look at as well. You can look at table.econ, run that one. Oh, did I call this something else? One thing we can do to evaluate this, we can either look at the data view, click on this to be able to see again. Oh, I called it current econ, that's right. Or I can also type head into the console down here at the bottom. I can type head dat to be able to see the first few of each column. And so you'll see that, yes, current econ is actually what I want. I can copy that over. If you get this unknown column, this usually means that you've misspelled your variable. Let's recall also that when we're talking to specific variables, we use this $sign in between the object and the variable name to indicate, it's kind of like the postal code of the entire variable. This means I'm selecting a specific column, and that column is either called Trump, or it's called age, or it's called current econ. Look at this one. I'll actually say no recodes necessary. Here, I'll look at a table of these guys. You'll see once again I've got -7s here, only 2 of them, but those 2 could be very meaningful, especially because our scale only ranges from 1 to 5. Think about this, if our thought that these were real codes, it would say there's two people who are so impossibly negative about the economy that they've managed to rate themselves as -7s. But of course, these people could be extremely positive about the economy. At the end of the day, the -7s mean that they aren't being measured on this scale that goes from 1 to 5. So we need to recode, once again, we need to recode -7s. And then finally, I can go back to down to my table, paste this back in, and we've got the last one we need to do is PID. So let's look at that one. Create a table of that variable, and we'll see that I've got variables, descriptions that go from 1 all the way to 8. That's weird. I was supposed to have 1, 2, 3, 4, 5, 6, 7, and instead I've got this 8th category, and so that's something that I really want to go back to my code book, right? Why are there 8s? And what does it mean? I can tell you, I'm pretty sure that 8s mean some other party or refuse to answer. And so these 8s are also a problem as well. We're going to want to do something with them. Either we can say that we can move them into this 4 category, which means that they're sort of pure independents or they're something other than partisans, or we can remove them from the data set altogether using a method that I'll show you in just a moment. One last thing I could show you is this table command will allow you to take a look at the proportions. This might not be a great one to look at because it's so messy, but if we looked at, for example, current econ, we can look at the proportions because I've just divided this by the n row, the number of rows in the data set. So out of the 3,000 or so, we can see that about 0.06% are a -7. That's a very small number, obviously, because they were miscoded. About 24.5% say the economy is very good. 20.9%, almost 21% say the economy is pretty good. 35%-ish say the economy is okay. 14% say the economy is bad, and only about 5.6% say the economy is terrible. And so this also, again, helps me to establish, does this look right? Does this seem like the right kind of distribution or shape of the data? We'll see more examples of these tools in just a moment. I can also use str to take a look at the different types of variables, right? And we can see here that, as expected, all of these are numeric, which means that there are no random alpha characters. None of these columns accidentally had one that was called like, oh, what birth year, 1960B or something, right? There was no miscode in there that resulted in some sort of alphanumeric character getting in the mix. Maybe 1Q84, a famous book by noted author Haruki Murakami. There's no 1Q84s in here in the birth year variable because all of these are coded as numeric. I'm going to hold off on this just a second into getting into the next part of this, because what we need to do ultimately, the big problem here, is that we actually need to now fix this data. We're getting to the point where we've observed, we've documented, and we've noted that there are problems here. And so what we need to do is go back into our Excel sheet and make some necessary changes. Now, I want to be clear that RStudio can do this, and it's very powerful in doing this, but because this is not a programming class, and I don't want to get too far into the actual sort of details of programming these changes, it's easier for you if I just show you a quick trick to doing these recodes in Microsoft Excel. So that is the topic to which we will now turn. So we've identified some pernicious problems with our data set that we need to fix, and it's very easy to do so. What I'm going to do here is select this column. Remember, we can use the B tab up here, click on B to select this entire column, and I'll be able to use the Find and Replace tool. You can press Control F, or you can come up to the top right to Find and Replace to be able to pull up this little box, which will allow you to replace values in each column based on their values with some other value that will allow us to easily remove missing data. And so what I'm going to do here is I'm going to say find what? Well, -7s are a big problem in our data set. So we're going to find the -7s, and we're going to replace them in this column with nothing. Now, it might seem counterintuitive. You might want to think, why don't we put an NA in here, or a space, or a dot, or something to indicate that these are missing values. It turns out that R will handle these best if we just replace them with blanks. And again, spaces are not sufficient. Spaces will be treated as a character, which will be a problem. It'll mess up the type of our variables. Instead, we want to replace these simply with blanks, with nothings. And so if I hit replace all here, we'll see that there's 15 replacements that are being made. We can do the same thing for those pesky 997 values. We can replace those with nothings. Get rid of those. Current econ, we can again select that entire thing. We can find that. Remember, we know that we have -7s in that data too, so we can replace these with blanks. So like those 2 replacements are being made. PID, we saw that we had a weird problem there where we had some 8s in the data set. We can take 8s. We can also replace those with blanks and make 115 replacements there. And so all of a sudden we can see that we've got blanks in our data set, which allow us to more accurately describe these weird values so that they don't interfere with our quantitative analyses that we'll be performing in just a little while. So what I'll do here is I'll save this data set again. It's very important that we do this first. Save that data set. Make sure that there's a new version here, because what we'll do is we'll come back into RStudio and we're going to take this old version. Again, RStudio does not automatically renew this based on a previous save. We're going to take this, we're going to use this little brush tool or this little broom tool to eliminate this old out-of-date version of our data set, and then use import dataset again from Excel to bring in the newly saved version of our data set. So again, we're doing a little version control here just to make sure that we're not dealing with that same thing. A lot of times students will come back to me and say, my recodes didn't work. All those weird bad values, all the -7s or whatever, are still in my data set. And I'll say, well, did you try reloading the data back into RStudio the second time? And it'll turn out that that is almost always the problem. So here we go. I've done that again. I've got my 3,165 observations of 6 variables. But if we go back to the descriptive analysis tasks, right? We can make tables. Let's look at PID just to make sure we got rid of the 8s. We can run that. We'll see. Look at that. 8s are gone. That makes us feel really good. But part of the problem here is that there are lurking inexplicable NAs, right? The NAs are still existing in our data set. So the very first step that we want to do here is we want to get rid of NA rows in our data set to make sure that we've just completely eliminated them. So we're going to use that tool that we used from the previous descriptive analysis, NA omit. Let's actually bring this in so that it looks the same. Dat equals NA omit dat. So if I highlight this, I run this again, we'll see what happens. All of a sudden we see that my N has reduced. And that's because I've eliminated those values for which there was this problem of missingness. So now we've lost some of our observations. We're down to 3,020 with what's called list-wise deletion. But again, all of these people are people who have what's called complete case information. We have people for whom we're not missing any of the values. That's very important. What it allows us to do, once we've gotten rid of all of those NAs, now we have a fully stacked data set with no blanks or no gaps and no miscodes. We've got the ability now to use some additional commands to look at this data. So for example, we can use the summary command to be able to see the minimum, the first quartile, the median, the mean, the third quartile, and the max of our continuous variables. So the mean here being a pretty important property. That means that on average, right, this person in the middle of our data space was about 50 years old. The median, of course, you can read about in Forestier as being a slightly more robust to outliers variable or statistic, and that is about 55, so more or less middle age. That's helpful to see. We can also use SD to calculate the standard deviation, essentially how much spread there is in that data for the continuous variable. That's the kind of thing that you can report in a discussion of your measures. So this looks like a pretty good distribution of age, given that the standard deviation is 17 and it's centered around about 50 or 55. The last tool I want to very briefly show you in this video is the quick plot function, which is something that's contained in tidyverse. The qplot allows you to create what's called a frequency histogram, which is essentially a bar chart showing you how many of each variable or of each level of a variable exists in the data set. It's very easy for you to take this and replace this thing after the $sign with your own variable, and then also replace the main, which is the title of the graphic, and the X label, which is what is the actual content, what's the description of that variable that we are creating a histogram for. If I take this and highlight the whole thing, remembering to highlight that bottom parentheses, that closed parentheses is an important piece of this code. If I get the whole thing and I press run, you'll see that for the first time in RStudio we'll be able to create an image, which is very exciting. It's going to give me a little complaint here. Using bins equals 30, pick better value with bin width. That's okay for now. We can ignore some of those warnings. What's happened is it's actually created my nice figure here. We've got 1s, 2s, 3s, 4s, 5s, 6s, and 7s. No 8s, thankfully, because we performed that recode. And you'll see what this shows us, since we've brought in some of those value labels down here in the x-axis description. 1 are strong Republicans, and 7 are strong Democrats. And we can see essentially that we've got this very interesting sort of balance here of people who are pure independents all the way across the spectrum. Really what this shows us is kind of a political polarization to some extent, right? We've got actually, if we add this up, a fairly even number of Republicans and Democrats in the sample. But I mean, really, this is a pretty nice way to visualize what we're talking about in terms of party identification and its distribution in our sample. So you can also do the same thing with your continuous variables. You know, this one you can specify a bin width of 1. I'm going to look at age here in the qplot. Again, that earlier variable. And you'll see that the age variable, because I've specified this bin width, or essentially each bar here, each little chunk is counting 1 additional year of age. We can see this is a very granular description of age. Looks like the baby boomers are pretty well represented here, right? People who are about 65 years old. This is actually a great way to visualize the baby boom in a weird way. There's a real missingness here of people who are a little bit like people in their mid to late 40s. I'm not sure why that is, but that could just be because of the randomness of the distribution of the sample. Regardless, some of these tools are ways that we might be able to better describe our data once we've made those necessary recodes and omitted, again, the missing values that will allow us to eventually do more advanced analysis. So when you're working on composition 5, make sure to take a look at these .r files, which will give you the code snips that you'll need to be able to reproduce those analyses for your own projects. So good luck with that, and I look forward to chatting about it in office hours and for the rest of the week. So long.